are in SketchUp.
Okay.
Here's the thing. Rhino takes and recognizes SketchUp files directly, but there's a specific way you want to bring it in. Alright? So we're gonna go through the process. And I took Ryan as an example because he got all these weird, crazy angles. I feel like if you can do Ryan's, you can do it. You know what I'm saying? I mean, y'all probably got some crazy angles too, but hey, we can do it all. So, first things first, you need to save out of SketchUp as a SketchUp 8 or later, okay? So if I go to File, Save As, under Save As, I can save SketchUp models off from every other previous version all the way up to version 3, which was a long time ago, okay? A lot of y'all were in diapers, now let me stop.
You said save it under what?
So save it under version 8 or later. So I have SketchUp now, which is like 18 or 19, whatever. Then I have the 2017, 16, 15, 14, 13 version. Then it can go down, it just goes by numbers 8, 7, 6, 5, 4, 3. It doesn't go down to 2 or 1. We don't need version 2 or 1. Okay? We really don't even need that with 3. But the Rhino you guys have, or your computers, is Rhino 5. On these computers, is Rhino 5. They came out with a Rhino 6 now. So for Rhino 5, we want to save down a few years because Rhino 5 is like years ago. They had Rhino 5 out for like 4 or 5 years, 6 years probably before they come out. So version 8 is the more safe version, okay?
And we can just save that under like our USB or file.
Yeah, so you can save it under your main file, but what I always do is I'll save a file and I'll just call it underscore V8.
Okay.
Splash.
Splash, yeah, we can splash the V8, but I'm not the file name. All right, so underscore V8. Now here's the thing. Before you export, it is always good. You see how this is right there at the origin? That is a very helpful thing when trying to locate, place, and function as you move between software. So always locate near to your origin, okay? This is your origin point for the whole file. You always know that these files are without extents. I can make something 1,000,000 feet long by 1,000 feet wide, okay? And if I got something way over here, and then I import it, I will not even notice it. I won't even see it, right? But not only do you want to make sure your object is close to your origin, you also want to make sure your your file itself is the right scale. Now your SketchUp files, generally, you guys don't have scaling issues with your files, but just make sure you're in the architectural scale, and then you'll be fine. 2 things. We found something out when I was giving my last tutorial, and I'll tell you. It's actually a pretty cool secret. Generally, when you export something from another software, you would decide to import it, right? Now, I didn't export this out of SketchUp. I just saved it as, right? Sometimes you might, because it recognizes the SketchUp native file, I can save it as a SketchUp native file. But sometimes you have to select it and export it as a DWG or a SAT file or something, depending on what you're trying to open it in the next software. But SketchUp to Rhino have a pretty good relationship. They work well together. So you don't need to change anything as long as you save it to version 8. If you have Rhino 6, you probably don't need to save it down, but or maybe you need to save it down 1 year or something, but for the most part, it should be fine. But while I'm in Rhino, what I saw, because typically you would go to File, Import, and if you were to import, what you would have to do is before you import is you want to set up your units. If I want to set up units in Rhino, what do I press?
Units.
Units. See, y'all can get out. That's why I love Rhino. It's so easy to learn.
Sorry, I'm supposed to be in Rhino now? Like we get another time?
You can do this or you can watch. It's up to you. You can be doing this with your files. It's completely up to you. Now, when you go to units, you can set up your units. Rhino a lot of times defaults to millimeters and decimals as a way of it communicates. But what you generally want is either feet or inches. It is up to you. Depends on how you work. Just know that whatever unit you put in up here, if you just type in 1, it's going to be 1 inch. If you have by inches. If you go by feet, you type in 1, it's going to be 1 foot. And you guys are architects or developing architects, so you should know the difference in how to work between feet and inches, right? 12 inches in a foot, so on and so forth, blah blah blah. Now, how it displays is also important. Always display it in feet and inches. That's very important as well. But what we found out, because I can set that up and I can import it, but that imports it into this file. Or if I set things up in SketchUp appropriately, I can just go to File, Open. So first let me do File New. I think it's the same name. Oh no, I did change the name to V8. So if I go File, Open, it'll ask, do you want to save the changes? No, I'm not going to save the changes. I'm going to open it instead of import it. my concept tower. Now make sure that this on the side, because typically it always opens a .3dm file. That's the native file for Rhino. Make sure that it knows to open SKP. Okay? If I go to SKP, then I can open any SketchUp file directly. So I open my SketchUp file. There we go. When I open a file, it will ask me this here. Now this is important. I'll explain to you a little bit how it works. Trim meshes, import faces as a trim mesh, trim planes or mesh. There are sometimes advantages to having something as a mesh, but you're gonna do trim planes. Here's why. A mesh is basically you have all your model 3D geometry. You know 3D geometry. We all know what that is, right? Stuff you created in 3 dimensions. If I do like complex forms, and I want the form, and this is very important, that those smooth curves come in smooth and clear without any distortion. That's the term, without any distortion. What it can do is just flatten it and say, I'm no longer remembering any of the parameters because I don't want to get this wrong. I'm just gonna flatten it as is, and you can then import it into any software and it will not lose its actual base form because it flattened it. Okay? The problem with that is, if you flatten it as meshes, number one, it triangulates it. It makes a bunch of little triangles that accommodate for every slight turn and curve of it, right? It triangulates it. You guys know what something triangulated is? You've seen that software before, right? Where a bunch of triangles go across to define it. Triangulation, right? Complex curves and shapes are all based off of the way all software do complex curves and shapes is mathematics, right? It uses math to say this arc with this equation on a constant creates this form, and it's always defining it as an equation, right? But then when you flatten it, it triangulates it and says, all right, now we're just remembering each triangle that created. We're no longer thinking of it as a math problem. And therefore, it's no longer a parametric or a smart shape or object. And but no matter what, it ain't gonna get a math wrong, it ain't gonna distort nothing, because some software knows the math. Some software doesn't know the math. So we can distort and lose things sometimes. But if you mesh it, it triangulates it all, and it just carries it over as triangles in space.
Oh,
Okay? So I get that? And it'll maintain it throughout consistently. Well, you don't have to get because we're using this.
Okay.
Trim planes is gonna remember the planes as you created them. Every plane you created in SketchUp, you drew this rectangle here, you drew this rectangle here, it's gonna remember your planes.
Okay.
Now, while it's not gonna look like one molded form, it will remember and allow you to reference and click on again all the reference points that you used to create it in the first place. You understand that? So that is actually, if you're going to recreate this in Rhino, the best way for you to do that. Okay? The whole join and import, you can join edges and faces. That can sometimes matter, but it's not gonna matter for you guys, okay? So whenever we talk about the textures and all that, that's if you're rendering out of any software, which you wouldn't be running out of any software. Even if you were, you would redefine materials anyway. So it doesn't matter either, okay? Any questions so far? So we'll go to trim planes, okay. All right, so this is Ryan's model, right? Imported, I didn't import it, I opened it. And what you might notice is, hey, it's right there at the origin, right? You with me? Now, if I wanted to check the units, let me type in units. Oops. My units are inches, that's great, that's fine. But coming from SketchUp, my display
How do you check
distance
the units again?
was
Typing.
how you type units again?
Typing units.
Type in units, all right? Whenever you guys ask yourselves, how do I do this? First, type it in, okay? And if it's not that exact word, I promise you it's some sort of a synonym of that word, okay? So, like, just start thinking of synonyms and see if that word might work. And then you can even Google how to, and it might be the wrong word, but how to do this in Rhino, and then Google what is perfect and tell you the exact word to type. Okay? How do I do something like stretch? You right? Although you can just type in stretch. And it might just say, oh, extend. You get what I'm saying? So be sure to.
When I put in a unit and push enter, that doesn't pop up.
Plural. Units.
I know.
Well, first off, hit escape. You're probably trying to type something. Hit escape, type in units. UNITS. UNITS.
Okay.
Yes, there we go. I'm gonna sound UNIT. Yeah, I don't know. That's our young. Anyway, so when I had it in SketchUp, it was already set up as inches, which is great, fine. I can go to feet if I want. Don't really matter. Sometimes if I go to feet though, it might say, do you want me to scale it for you? Like, no, I don't. That's basically saying, do you want me to scale it, the difference between feet and inches? Cancel. I'm gonna just leave it at inches because I don't want to play with any of that. The moment you play with that, you better make sure you rescale your model to make it right, because sometimes it can go wrong, okay? But type of units. I'm gonna leave it at inches, that's okay. That's how I supposedly created it in SketchUp, so I'll leave it at that. I'm gonna make this I'm gonna make this feet and inches. Every time you work in feet and inches, this is how we display it in architecture. As this feet and this many inches, okay? Y'all cool with that? Alright, so I'm gonna display this as feet and inches.
Wait,
And
are
then
you
here
not
I go.
changing the scale to 16th inch?
Say that again?
You're not gonna change the display position to 16? Is that what we're printing at?
No, that's another.
Okay.
That's another thing. So that actually gets into the question I was about to get into. A lot of people say, all right, well, do I scale it now? And listen to me, everyone, I strongly recommend that you do not scale it until you're ready to print. It is just like when you print something on a printer, you don't get it ready for the printer until you print. You know why? Because you are still designing or working at, like you model and create at your design scale.
Okay.
If you intended your window to be 5 feet, you draw it at 5 feet. You do not scale it down and, oh, well, what is 5 feet at a 16 scale? Now I gotta do math. What you're doing is giving yourself more work that the computer already does for you. Okay? If you are having to calculate the scale of something when you draw, it makes no sense given that all you have to do is scale at the end and the computer automatically does that for you. You draw your windows and doors and walls at whatever size, right when you scale it down, they know all of that. You don't have to draw at that scale and figure that out. That's a waste of time. You guys understand?
Mm-hmm.
When you're ready to print is the only time you prepare to print. Everything else you work in real world design scale styles. Alright? Now I'm going to show you, if you scale, I'm going to show you a cool way that Rhino scales. This is one of the things that's cool about Rhino. I select this and I start to scale. Right? You notice that, when you type in stuff, I can scale something in 1D and I can scale something in 2D. That's a really cool thing, okay? Rhino does this unlike other software. I can scale in 1D, meaning meaning that if I click here and I want to scale going in this direction, all Rhino does is scale in that direction. See that? Only in that one direction. Cool thing about it is I can pick in any direction. I can pick it at an angle, say I want to scale only in this direction. Then Rhino only scales in that direction. And no other direction. Y'all get that? That's a weird distortion. Like, who wants something that actually looks like that? Right? That's kind of ugly. Well, no,
That looks nice.
Look, that's just improved Ryan project.
Right.
But anyway, so I can scale in 1 dimension. I can also scale in 2 dimensions. Scaling in 2 dimensions means it'll get wider, it'll get longer, but it won't get taller. Okay? See that? It's getting longer and wider, but it's certainly not getting any taller. Okay? And you can do that across different dimensions. You can scale taller and wider, but not longer. You get what I'm saying? You do it however way you want, all your different axes. But what you guys will be using for this is your general scale. You want the entire object to scale. All right? Another thing I'm going to show you, which is super important. It's already on because I had it on already, but you see these little pieces down bottom?
Yeah.
These actually really help you to get around and function quickly and readily.
Where's your feet? How do we get to that?
All right, it's not on. Yeah,
Oh, snap.
Oh, snap. I turned mine off. Oh, snap. You ever heard architects make that joke or like computer drafters? Oh, snap. Like, oh, snap is important. Okay?
So I should click that?
Oh, no, well, I'll get to it. I will show you. So the O in O snap means object snap. And all that does, and all that means is, how do you define the ways you react to objects around in your scene? Okay? If I click on O snap, all of my O snap parameters or options will come up. I'm going to quickly go through them. So right now, if I want to draw a line, and I say I want to draw a line that starts here and ends there, I can't do that. I get that without O snap, I cannot do that. Y'all with me? Because I needed to know and recognize this endpoint. This is why it's not a mesh. If something was a mesh, even if I turn my O snap on, it would just recognize it as triangulated things. It doesn't remember the points or the planes that you originally established. You get what I'm saying? But if you do it as trim planes, it knows the coordinates of your planes. So when I turn O snap, I can snap to the endpoint. No, this is the endpoint. You see when I hover, it tells me that's the endpoint. If I want to snap to the midpoint, it says, hey, there's your midpoint, right?
Okay.
If I want to snap anywhere near, it'll just kind of let you know you're kind of near or along that plane. Tangent and near are actually pretty much the same thing.
Okay.
Tangent lets you know like along, but more on a circle, okay? Points, if I actually place, you know how you can draw and place points? This is a way, and I just like, and all I want to do, it's like I place, the way I design is by first placing my points, plotting points in 3 dimensions. To say I want this to be at 0, 0, 0, I want this to be at 0, 1, I want this to be at 0, 1, 1, right? I want this one to be at 1, 2, 1. Did I get that? All these points in 3 dimensions. And then I turn all of my snaps off except for points. I can just draw around and react to those points of what I'm creating. You get what I'm saying? Rhino is amazing in that you can be super exact. Remember the 4 entities I talked about in Rhino? What are the 4 entities I talked about in Rhino? Points?
I think I might skip one.
What do points connect together to create?
Lines.
Lines. What do lines connect together to create?
Sheet.
Surfaces.
Surface.
And planes.
A surface is a plane.
What was the planes?
Surfaces. And then what do surfaces come together to create?
A 3-dimension.
A 3-dimension what?
Sheet. Form.
What's called a solid or a polysurface. We'll get to that. Okay, but I can snap to just my points. I can snap to center points, that's like of a circle. I can snap wherever 2 lines or 2 objects intersect. I can turn my snaps on to let me know, so I can say right where they intersect is where I want to start drawing this, right? Sometimes matters a lot. Perpendicular, this is important because it'll let me know whenever I'm like reacting to a plane, if I'm like perfectly 90 degrees with it. Perpendicular, okay? That also matters. Quad, knot, and vertex, we don't need to get into, okay? That's more like for stuff that you will not likely ever use. Now, one of the more important things that people don't know about Rhino, another really cool thing about Rhino, is I can snap. One of my snap options is project. I can project my snaps. This is where it becomes important. I want you to watch simultaneously this plane and in 3 dimensions, okay? Y'all with me? So let's say that I want to draw a line that outlines these corners coming from the bottom. And I say, all right, I want to do this, I want to do that, and I want to come here, here, and here. And you see how it's actually going in 3 dimensions right here? Now, when I'm here, I don't know that, do I? And I can be doing stuff, going back and forth, and now I can't even see it, right? So project is actually really good because it allows me to do that without changing my planes. I'll reference that point, but it's still in the same plane. You see how I was referencing that, but it's staying in its own plane? So now when I look at it, okay, I get to stay in the same plane. So what I'm drawing here in this view, it actually looks the way I see it, okay? Projecting matters, especially if you're drawing from plan view, and you got all this stuff going this way. You just want to get the outline of your plan or something, right? Flat to the ground. You don't want your walls jumping and popping up and down, or your lines popping up and down. Project helps with that. And last but not least, this is quick function. Like I can, sometimes when you want to draw free, let's say like you want to turn your snaps off. I got all these snaps on that I need, right? I don't want if I want to turn them off to go and click every one, click 7 times every time I want it off. I can do what's called a quick disable. They're all gone, they're not working, and then when I want them back on functioning again, turn them back on, just like that. I can, and another really good thing about Rhino that AutoCAD you can't do, because AutoCAD has snaps, y'all know that, right? AutoCAD snaps are great for 2-dimensional drafting. I remember I told you that, right? And as you can see, because that's project and it has all these other things, that Rhinos is okay for 2D drafting, but it's really good for 3-dimensional, right? Really good for that. But one of the things, shoot, I forgot exactly what I was about to say. I was about to talk about something, but I just forgot. Oh, one of the other really cool things about Rhino, because it's in 3 dimensions, is I can be in the middle of a line command. Let's say I'm trying to draw a polygon. Nobody told you the difference between a line and a polygon, right? Alright. It's like I'm in the middle drawing a polygon. And I say, oh, I want to snap to this now, right? I want to enable my snap so I can snap here. Now I want to disable it so I can, do this other things. And now I want to project, and now I don't want to project. I can simultaneously turn these things on and off while I'm in the same command. Okay? Because in 3 dimensions, sometimes more likely to require you to do that. Right? One time you want to snap to this, one time you want to project, then you still need to line it while it's projecting against this angle here. Now I gotta go in 3 dimensions and actually grab that point over there. Y'all get what I'm saying? So Rhino's actually really, really good at that. In AutoCAD, if I want to change any of my snap options, I have to get out of my command and then change my snap options. Okay? Yes.
Another question was, what's building our thing? Because, our site plan or like the thing that we're supposed to be putting the tower on, some of it goes at a, it's going it's like rising.
Yeah.
And if our model is like kind of flat, but we might need to like.
How do you see something flat when something that changes?
Yeah, like how are we supposed to know where we're going to need to put it at?
It's a good question. I will answer that question.
Okay.
So
I will answer that
how
question.
do you scale things down to nonsense? Like, are you select?
Okay.
Scale?
Alright, I will show you that too. I will show you that. Not right now. I got both of y'all on those things.
My
Yes.
other question is, okay, so how do we know what needs to be closed or what we need to fix?
That's what I'm gonna show you right now.
Okay.
That I'll show you right now.
What if it's already not closed? Or if it's,
I mean, I see
Now,
blue
answer that right
lines,
now.
yeah.
but
Okay. Y'all, it's so funny. Like sometimes, and it happened the last time. As soon as I ask a question, I'm literally about to talk about next. Because what I just talked about might lead you to want to ask the next thing. And it's like, I know, so I'm gonna talk about that next. Right? So let me talk about it. Although the
I mean,
other two
because
questions I
his-
asked were not there. Those
his
are-
model kind of forms with his site plan depending on where he's putting it at.
Yeah,
it has
potentially, but what if you have a flat bottom?
Right.
I get you. I understand. All right. So everyone understands how the snap functions work, right? How you take advantage of the snap functions. A little bit. All right, it's close enough, right? Now remember, I told you that Rhino works in 4 entities, right? Points, lines, surfaces, and polysurfaces, right? Now, polysurfaces and solids are similar but not the same. All solids are polysurfaces. Not all polysurfaces are solids. But Revit recognizes polysurfaces and surfaces as something different. Okay? But you should still think of it as the same because the creation process is similar. When you create 3-dimensional geometries, now look, if I take 2 points, I create a point here, and I create a point there, right? Then all I gotta do is create a line between those 2 points, and there's a line, right? If I create 3 lines, let's say if I want to create a surface, all I need is 1, 2, 3 lines. There's a surface. I see that?
Right.
Okay? But if I click on this, Revit sees this as an open surface. If ever you have something open and it doesn't say closed, it's not going to be right.
Right.
Okay? And you might want to, but do not try saying, well, I'm gonna just, you saw this is, I import this, what does it say? Open polysurface. The first thing a person might try to do is say, I'm gonna just close this and it's gonna be all good. When you import something so complex and it comes from SketchUp, you never know coming from SketchUp what planes and what lines are perfectly connected or even or consistent, even if you try and close them. So you can create awkward or inaccuracies, more so if you do that. And since you guys need to learn Rhino anyway, you should reference this, but remodel it all. Okay? Now, in order to do that, you're gonna need something that says closed polysurface or closed solid, something closed, right? There are 2 ways to create closed objects in Revit. I mean, I keep saying Revit. I teach so many different software. I'm sorry. And Rhino. Okay, I can create a box. If I create a box like this, just like that. Let me show you that right here. This is a box. If I click this, close, extrusion, close. I can 3D print that, right?
Right.
It's good. But the moment I explode this, 2 things happen. I explode it, whoa, it's not closed anymore, obviously. Now it's just 6 individual sides.
Right.
And if even though technically these 6 individual sides together are closed, they don't know that they're together. You didn't define them as together. They just happen to be sitting next to each other, right? You have to tell them, no, I want y'all to connect and form a unit, right? So now that I made them 6 individual surfaces, anytime something is a surface, the way Rhino recognizes it is by looking at its midpoints. Okay, it creates midpoint lines. Even for this triangle, midpoint lines.
So what makes that triangle open? versus the box?
This is open. They're all open surfaces. They're not closed.
Well, I mean, that's open now because you exploded it. But
Yeah.
what made that open when it took place?
This triangle,
Yeah.
it has no thickness.
Oh, okay.
There's no thickness. It's just open.
So, okay.
Okay?
Okay.
So, yeah, here's the thing. If I then take all these and join them together and tell them to recognize, what's going to happen to this box?
It'll close.
It's going to close.
Hollow.
How's it going to look?
Like that?
It's going to look like this. It's not going to, like, take these lines away in the middle. All right, you're right. It does not. So if I type in join, this was a closed extrusion. Now it's a closed poly surface. Okay, because there are two different ways to create things in Rhino. You can do it as an extrusion, or I can just say, I'm just gonna draw a bunch of surfaces and then join them.
When you just deleted that face, is it still a closed poly surface?
Well, I exploded it again, so no.
Okay.
So I can create a bunch of different surfaces, define them however I want, and then just close them all. I can, and so what I told Ryan to do,
Bless you.
he wants to do a 3D print of this mold. I told him, well, what you would do is literally go through and triangulate and draw every last one of these surfaces. Join them all together. It will be a closed poly surface that you can 3D print that. But you want to shell it, right? Because if he just 3D printed this, it would be one big heavy mold with a waste of material that y'all paid for. But if he were to shell it at it, fairly thick because it's printing pretty small, then it would hollow it out and print the exact same form. You understand that?
Mm-hmm.
That's what you should do. So you can go the route of, well, let me create a box for this that looks like that. And then also what people don't know, because he could also do it this way. If I create this box and I do this one thing called solid points on, it's about to be slick. I can take this box and mold it however I want. You see that? But you notice that from the moment I shifted that, it switched from an extrusion to a what?
Perspective.
Oh, let me show you. First is like this. Then those midpoint lines come in. What does that tell me? It is a poly surface. It was called a closed extrusion. Now it's no longer finding its identity off of science, off of you extrude me up 10 feet, you make me this wide, you make me this wide. That's not how it's finding its identity anymore. Now it's finding its identity by breaking down each one of these surfaces. Okay? You understand that? So now I start doing some stuff like, what Ryan had, right? I turn my points on, my solid points on, I move this up, change that around, right? I do all this crazy stuff.
So he's recreating it, but in a different space?
Yes.
Is that what he's doing?
So what you can do is you can mold it like this and create it. You can create it by points like that, but it's gonna be hard to figure out how many points you gotta create and mold it like that. So honestly, the best way to do it is there's this tool where I can create a surface from clicking any 3 or 4 points. 1, 2, 3, got that surface done, right? And what I would do is I would put this on a different layer. I would actually start a new layer, and I would make it something bright. Call this join new lines, or new surface. New surface. And I'll make that my layer current. I will lock that layer because everything's locked in a layer. And then when I start creating these, it will just create on top of that. I gotta make sure I click the right points and I'm snapping right and all that. Because if one of these points don't align, then it ain't gonna create right. Y'all get what
Now
I'm
I have
saying?
a question, are you only focused on the exterior and not interior? Remember there are
Well,
things
it
that
depends on what you
can
want to show. At 16 scale, probably just the exterior.
Okay, so what we need to do is, you see how you have an extreme, because he has stuff within inside of the stairs and all that, so
you're
you
not
can
gonna
delete all
show
of that.
that much detail in the 3D printed 16 scale. It's not gonna pick that much detail.
So,
If you feel like it could, you can try. But honestly, because with his, like, it's on the inside of this building, you have to see through these to show it. He's not printing windows. So
Yeah.
even if he showed it, you can see it.
we're just printing the shape of it pretty much.
Right now, you just kind of print the shape.
So-
Unless you got openings where you can see inside. If you have it, let's say like his design.
Like we have
that's
balconies and we have roofs,
Let's say like
decks.
let's say like his design was something like that,
Yeah,
right? Then you would probably try and show some of the detail because you can see through to it.
okay,
But all his geometry was hiding it. You couldn't even see it.
okay.
That's what he designed around. So you're not necessarily gonna do it that way.
But what
Right.
about like glass?
It depends though.
Do you leave glass as like a just solid wall, or would you just leave it?
Right
open?
now, everything is just one molded solid
Okay.
because our 3D printers aren't capable of recognizing the difference.
So then you can't really show the interior.
That's what. The only way you would show the interior is if you have like an extra on the wall that's taken away where you see into a natural, right? But no,
Oh, okay.
like
I just want to make sure so we don't have to. So we literally can just next to it copy whatever created, or we can just close the surfaces on what we've already created that we
Right.
pulled in.
Right.
But everything like when we pull up our stuff, our stairs, all of that pops up. So my thing is we're not worried about any of that stuff. We're just working around it.
Right.
Okay, that's why I just want to make sure we
unless
can
you
delete
have
it.
openings to it to see it. But even then, I don't think those 3D printers will pick up that level of detail at that
So
small scale.
okay, I have stairs outside my building, so how?
If you have extra stairs outside building, try and see it. If it can pick up the detail, like your stairs are like 1 feet, it might pick up. It might pick it up.
Because I know downstairs he was talking to us about columns and how the 3D printers don't like to pick up columns. So
He said to make it thicker.
Yeah,
Yeah,
see,
they-
columns are harder because columns are literally a little thin profile every layer. Every layer, and expect it to stay perfectly consistent off of them little small things as it goes up because it's printing the column longer. If it did it
Oh, I see what you're
wide
saying.
flat,
Yeah.
Because it's like it keeps rotating.
Yeah.
Basically, it causes a problem.
And then it's moving so much.
it's making it likely be an inconsistency with that.
So-
These 3D printers are good. They're the functional 3D.
So what about like handrails too? Because I have handrails that like.
No, don't forget the handrails.
So just don't put those there.
Don't put the handrails in.
Okay.
So you
So
may as well
when
just put the
we-
shape of the box.
It's fine.
At the end, when we select the whole thing, it should say closed, poly surface, whatever.
Closed poly surface.
Okay.
Yeah, so what you would do is you can make items by taking these spaces,
Mm-hmm.
creating them all throughout, and he would have to like go like that, and then when he's done, he had to join, right?
Okay.
Now this isn't enclosed yet, but he would join it, and then that would, once he gets his whole mold done,
Mm-hmm.
it would say one single enclosed poly surface. Now his design is his design.
Mm-hmm.
You got stairs when you're outside, right? So you might create your stairs by doing single extrusion, saying, all right, this is my stair, right?
Mm-hmm.
I got 1 stair, then I got 2 stairs, 3 stairs, you get what I'm saying?
Mm-hmm.
And they might actually be like that. Now, you as long as it says closed, it's fine. But you can also, you might say, all right, well, I want to make this as one mode though. You do like this and like this and like this, right? These are your stairs. You might want this to all be one mode. So if you have it join, huh?
Which command?
Say it again.
Which command did you press?
Copy. That's copy. So if you try and join it, they're not going to join because they're already closed extrusions.
Oh.
Now, can you take a bunch of closed pieces, a bunch of closed, as long as they're all closed? Yes, you can. But the problem is, let's say like these overlap each other in space like that. I don't even know if they're actually overlapping. Okay, let's say like I had this overlapping in some weird way. Overlapping, huh? It's not overlapping, I can't move it right in 3D. Whatever, they're overlapping. They look like something like this, overlapping. Right? Now, I can't have them overlapping as close extrusions and have Revit understand, Rhino understand how to really print that. So what I can do is called, Boolean?
What did you say?
It's called a Boolean union.
Oh, bullet.
I union them. Objects, like faces can join, right? Closed objects or solids, you have to union them, okay? So Boolean union will get that done. You can start typing union and it'll come up. Okay. Boolean, yeah, Boolean is a funny word. But even still, so that's how you work with these solids.
I have a question.
Yes, ma'am.
Okay, so Ryan's is a little unique, and mine is just like regular rectangles that are stacked on each other. So, and we're making just like shells of them. So I would make like an extrusion of a box, but I would shell it.
So the best way to do like one shell is if you make it one mold,
Okay.
right? Now the other thing is that as you guys are doing stairs, let's say like these stairs are too small to 3D print. You can also represent stairs simply by saying, well, I'm going to do an angle. If I do an angle like this, you get what I'm saying? Like a ramp. Just represent your stairs as a ramp. You get what I'm saying?
Okay.
Why is it not going right? It's like it's missing. I'm trying to work it on. Oh, it's the wrong way. But even still, I'm not gonna get all that. You can do it as a ramp and represent it that way as well. That is my way if the 3D print is too small. You know, they just represent stairs. This is representative. That's another way. And then the last thing, so let's say that I got it all done. I'm ready to go. Now we're to your question. You said, right? I got it all drawn. Now I'm gonna act like this is my final. Although it's not my final, I'm gonna read this. This is my final. Yay, I got it. Right? Now I want to scale this down. Do not shell it. You could shell it now, but that's not your actual shell thickness. Because these 3D printers, you want to be a certain thickness, right?
Right.
So if you shell it before you scale it, you're not gonna know what thickness. So you gotta do math to figure it out.
So you
Again,
shell
you don't
the
wanna do
end?
math.
You do it at the end. Shell.
You do it once you shrink it.
Okay.
So if I scale this down, and I say, all right, right when I type in scale, not 1D, not 2D, just good old scale, right? It says first, where's your origin point for the scale? Origin point should be 0, 0 point. All right, now I could do it by reference, or I could just type in the factor already. I want this to get how much smaller if it's at a 16 scale? How many times smaller I want this to get? Somebody tell me. I ain't gonna tell you this. I'm trying to tell you this.
What did you say?
I told y'all.
How much smaller?
Say like 192?
192.
Oh yeah.
How'd you get that?
Cause you said it. But what is it? It's what? 16?
I wish I could clap right now, but I can't.
16 times 12.
Yeah.
If 1 inch is equal to 16 feet, right? That means that 1 inch is how many times smaller than 16 feet? 192, y'all. Come on.
Okay.
Do math. So the way I would scale this down is I want this to get 192 times smaller. I would say 1 divided by 192.
Okay.
Let's type that in. Got 192 times smaller.
Where does thing go at?
You got smaller. What you talking about? There you go.
Oh.
Look, that's smaller.
God dang.
Okay, now if I can't
Non-existent.
shell this because it's not a closed polysurface. But now if I would shell this, I would say, all right, I want to shell it 1/8 of an inch. Y'all get what I'm saying?
So that's giving it like a wall thickness?
That will give everything a thickness of 1/8 of an inch with hollowed out everywhere else.
So you just type in shell.
Type in shell.
One.
Now, whenever you shell, you got to pick a face that you want to uncover. The part that touches the ground is generally always the face. Okay?
And then
What?
what do you do after that? After you take it off?
Hit it, and it will shell.
And then you put the face back on?
No, the face is gone forever.
Hold on,
It's
you
literally
always
like a cup. It's like a cup. So if I turn around, I put water
So
in.
my bottom
So
is
the-
gonna be.
Open.
your shell. What?
I mean, that's
If you
okay.
shell it, that's one way of doing it. You could shell it so that there's a bottom. I mean, you could empty it out, hollow it out so that it still has a bottom. You could do that. But generally, in what Rhino likes to do is they want you to see that it's shelled, so they make one face open. Otherwise, you wouldn't know what's inside. You know what I'm saying? Now, after you shelled it, you could just create a new bottom and join those together. You could. But I don't think you need it. Sometimes people do that because you want to glue that bottom down or something, so you need that to glue. So you need to put that back in there so that when you actually 3D print it, you glue it down to your site. Put some glue on the bottom of that thing instead of just around the edges. Yes.
Now what about our bottom's supposed to be 20 by 20, correct?
20 by 20 feet. Yes.
Okay. So if our first floor is 10 by 10, you still gonna need that 20 by 20.
Well, that 20 by
Bottom.
20 is your boundary that you need to fit with that. Like, to start with that. That doesn't mean that you might not touch the ground when 20 by 20 at your when you meet the ground. You can meet the ground at 10 by 10.
Okay.
You get what I'm saying?
Mm-hmm.
All right. So with that, your shell is there. That answers your question, right?
Yeah.
All right. Now I got your final question, and we done. Just in time. So my question is, how do you place something on the site? Let me mark out your